Hard Armor Solutions presented by Contec. My name is Lisa DeRoba, and I will be the moderator for today's webinar. Before we start today's presentation, we would like to cover a few housekeeping matters that will ensure we have a smooth presentation. We've placed all phones on mute to cut down on background noise and to ensure everyone can hear the webinar. At the conclusion of today's presentation, we will provide information on how to obtain PDH certificates. The webinar is scheduled to last for 1 hour. We will have about 50 minutes of presentation followed by a question and answer period. When you logged onto the GoToWebinar window, a window will have appeared in the upper right-hand corner of your screen. This window will minimize by itself after a few seconds so that it does not interfere with your viewing of the webinar. If you would like to maximize this window, just click on the small red arrow and the window will be maximized. The blue box in the GoToWebinar window will allow you to minimize or maximize the presentation so you can view it in whatever size works best for you. If you have questions, please type your question into the question box. We will be taking questions throughout the webinar and try to answer them at the end of the presentation. Presenting today will be Jeff Gilkinson. Jeff is the Vice President of ArmorTech for Contec. Also presenting today will be Clayton Fawcett and Barry King. Clayton and Barry are each area managers for ArmorTech and have over 20 years experience combined in hydraulic design, construction of hard armor solutions. Now I'd like to turn it over to Jeff.
Thanks, Lisa. As Lisa mentioned, I'm Jeff Gilkinson, Vice President of ArmorTech. And we're very appreciative for the attendance today and look forward to a great next hour of talking about hard armor solutions and how Contec can help you with those types of applications on your projects. Before we get into the hard armor presentation, I wanted to take just a moment and talk about Contec's overall portfolio of products. One consistent theme with all of the products that Contec deals with is that in some way, shape, or form they involve water, whether it's conveyance, storage, spanning over, the treatment of water, or protecting critical infrastructure from the erosion of water. Somehow, some way, shape, or form, Contec has a product that can meet those needs. Our portfolio includes stormwater management systems, from detention and retention to treatment devices that include hydrodynamic separation and filtration systems. Best way to say it is we have the entire treatment train of stormwater treatment products. We also have a full range of piping products from corrugated metal pipe to PVC. In fact, we even have the most advanced drainage system in the market, which is a steel reinforced polyethylene pipe. But that's a presentation for another day. Our bridge products include precast, plate, and truss. And then finally, we have earth retention systems that are made up of our Keystone retaining wall products. Today our topic is going to be hard armor solutions, and we'll start off with Greg Gluns, who's going to discuss the full range of overtopping protections that are available for dams. After Greg, Barry King will talk about hard armor design practice for articulated concrete blocks, and he'll also touch on spillway design. Finally, Clayton Fawcett's going to walk through several project profiles to show where designers like you have taken advantage of Contec hard armor solutions to deliver efficient and effective results for their clients. So as I mentioned, our first presenter today is going to be Greg Gluns. Greg is a project manager for URS in Denver and has more than 15 years of experience focused on the analysis, design, and construction of hydraulic structures for dams. His experience includes both domestic and international projects and has dealt with spillway design capacities in excess of over 100,000 CFS. With that, I'd like to welcome Greg and turn over the presentation to him.
Thank you, Jeff, and welcome everybody. I'm excited to be here to talk to you this morning, this afternoon, for those of you maybe who are a little farther east. As mentioned earlier, I've kind of dedicated my career to working with dams and spillway projects, and so with my presentation today, I'm just going to kind of go over just a brief background of overtopping protection, why it's selected, some of the general design considerations with a specific focus on identifying the failure modes and opportunities that can be incorporated into designs to mitigate those, as well as to give kind of an overview of, selection of an alternative needs to be more about discharge and velocity requirements for your spillway, or the overtopping protection, but also for the foundation conditions, the structural considerations, and geotechnical also. Then I'm going to kind of end my portion of the presentation with a discussion about three situations or common alternatives that I've used and how we've incorporated those design details to help with mitigating the potential failure modes that we'll be presenting here. Just as an initial background, most of the interest in overtopping protection is a result of spillways on existing dams having an inadequate capacity. And this inadequacy is driven generally by two different things. One, the hydrologic conditions have changed in the methodologies that were used, or two, the hazard classification is changed due to downstream development. There are many alternatives that can be used to increase or change spillway capacity, from raising the dam, changing the abutment or spillway configuration, or overtopping protection. One consideration that needs to be thought about when selecting overtopping protection is that it introduces a potential failure mode that can lead to the dam breaching by directing water over the embankment. If the overtopping protection failures, you expose the underlying embankment material to flows or erosive velocities that can potentially lead to breaching of the embankment. The overtopping protection should also is typically used for auxiliary purposes as opposed to service spillway, and because of the potential initiation of an overtopping failure, if the overtopping protection fails, the frequency of operation is also a consideration here. Just wanted to provide a quick example of an overtopping protection failure. This was a small low-head dam, 20 feet in height or so, that was protected by a conventional concrete overlay. There was no reinforcement or water stop in the joints. Approximately 1 year before this photo was taken, there was an inspection of the dam where a 1-inch crack longitudinally was observed near the crest of the dam. The subsequent spring, there was a rainfall event that allowed the spillway to operate. There was about 3 or 4 inches of flow going through the spillway. And as you can see in this photo, the lower slabs of the chute as they enter the stilling basin have been displaced as a result of the hydraulic jacking or uplift from water getting in behind the protection, going down to the toe, and then lifting out the slabs. So there are many alternatives for overtopping protection. I've listed 6 on this slide here, but some of the ones I'm going to talk about a little bit more in detail as we move on will be RCC, conventional concrete, and the articulated concrete blocks. Something else to be noted is the history of performance. While numerous dams have had overtopping protection constructed on them, few, if any of them, have actually operated clear up to the design flows. So the overall long-term performance is something that's still in consideration. So from general design considerations, the 2 potential failure modes that come up the most often or of biggest concern are hydraulic jacking or uplift due to seepage or pore pressures that develop underneath the overtopping protection method. The other one is water that passes through the overtopping protection and then saturates the foundation materials and potentially causes piping around or adjacent to the structure, leading to the structural failure of the overtopping protection. Generally, from the frequency of operation, it's preferred if they operate less frequently than the 500-year flood. The PCA, Portland Cement Association, has recommended in the RCC, Concrete Overtopping Protection Manual, that they not drop below 100-year frequencies for those structures. Something to consider too is once you start directing water over the embankment, there's a potential to increase or change the phreatic surface, and this can either lead to the impact of the embankment stability or again back to the potential for uplift or hydraulic jacking of the structural material. One of the other things to consider in selection of the material for overtopping protection is the potential for differential settlement between the embankment and the foundation materials. Also similar with new construction, new embankments that are still expecting to settle, it's preferred not to provide overtopping protection on new structures. Something else to consider is the potential for debris or during overtopping events. If you were looking at like a gabion type structure and the debris to capture or gets caught up on the wire baskets that can help pull those apart. So that's something to consider if that's present in your watershed. And lastly is just general energy dissipation at the toe of the dam or at the end of this structure for the overtopping protection, that it's adequate so that you don't lead into head cutting and undermining of the structure. So some other general considerations about overtopping protection. By covering up the downstream of the face of the dam, it really limits observation of the embankment performance. So monitoring and long-term performance issues are more difficult to discern. The other one is, as the dam or embankment is overtopped, there is the need for have the water converge back to the toe. And so we need to protect the abutment contacts with the embankment. Generally, there's two options. You can extend the protection, as shown in the left-hand lower left picture here, down along the embankment contact. And this would work for both articulated concrete blocks. This just happens to be an example of an RCC protection. Similarly, or alternatively, on the right-hand side is more of a conventional training wall approach, whether they are parallel straight walls or a converging chute concept. Those are other options for keeping the flow off of the groin and protecting the embankment. So conventional concrete, some of the basic design considerations here is the jointing to eliminate the concerns with uplift pressures or minimize those. It's including a drain system, which you can see here on the left under the chute. Similarly, there's a key shown that it's integral to the downstream slab, and that's there to keep the downstream slab from getting elevated above the upstream slab and causing a hydraulic jacking condition there, where more water could be forced down through the joint into the foundation. Similarly, there's a dowel as well as water stop to help reinforce that joint to minimize the potential for water to be introduced into the foundation. If your foundations are amenable, you can also add anchors to help support the concrete slabs. As you'll see down on the bottom, just a typical profile for a concrete overtopping. There's also an inclusion of a cutoff wall at the upstream end to protect against wave action and erosion underneath the structure, as well as it increases the seepage path and reduces the uplift pressures there locally. Similarly, there's a cutoff wall down at the toe end of the stilling basin for the purpose of helping to protect against head cutting and migration underneath the armoring protection. So some of the advantage of conventional concrete is they really are capable for a full range of discharges and heights of dams velocities. You can incorporate defensive measures to protect against the failure modes. It can also handle some differential settlement, and then it's also suitable for more frequent discharges because of those additional protections. However, some of the major or larger disadvantages are construction duration, just the time to form and pour, the wait times between adjacent sections, and then just the overall cost. Depending on the actual configuration as it passes through the embankment, you can actually expose the dam to more risk during construction if the section of the embankment needs to be lowered for construction activities. Roller compacted concrete has a lot of the similar details for mitigating the potential failure modes that conventional concrete does. As far as like the drains and the upstream and downstream cutoff walls. This structure also, you can see the integral stilling basin for erosion protection downstream and taking energy out of the flow prior to exiting the downstream channel. As far as the advantages, it's suitable for higher discharges, maybe not quite as high as conventional concrete, but relatively high. Construction duration, it can be put together pretty quickly. And then we can also incorporate energy dissipation either through steps in the chute or into the stilling basin itself for an integral single product. The disadvantages are you really lack the defensive measures to mitigate differential settlement, water stop type material. And then sometimes the availability of materials or equipment can be disadvantaged to certain sites and locations in the country. As you can see in the upper right-hand corner, this is an example of a project where we had conventional concrete retaining walls down either side of the chute, and then we were constructing RCC up through the slope. You can see the sand filter material mixed to the concrete blankets between there and the RCC. And then the lower photo, you can see the completed project with the drain exiting through the face to release excess pore pressures or pressures that build up underneath the RCC section. From the articulated concrete blocks, we're starting to see, you might see some of the similar themes entering here. We want to have a drainage layer to minimize the potential for uplift pressures to develop. There's a little, there's velocity limitations for the blocks in comparison to a conventional concrete chute. The other area of concern is the flow convergence. If you want to wrap it around the abutments and down those groins, that those concentration of flows and complex hydraulics conditions are considered in the design of the blocks. And then last but not least is the seepage of water through the blocks and the gravel layer into the foundation or the embankment material needs to be considered both in the stability of the embankment as well as the potential for piping of the material. So from the articulated concrete block, some of the advantages are that it's a flexible system and has the potential to move. The construction duration can be assembled very quickly. So if you have to lower an embankment to do construction, they have a smaller window for being at risk. And it's a customizable geometry to fit site-specific conditions. Some of the disadvantages compared to the other two that we've talked about, the lower design discharges or velocities, and the potential for an extended use can elevate embankment pore pressures. So overall, at least, we've just kind of talked about a few of the failure modes that should we be aware of when you're selecting an overtopping protection, and that those failure modes and the selection of alternative need to be consistent with the geotechnical and hydraulic suitability for your project. So with that, I'm going to turn it back over to Lisa, and she's going to start with your first question.
Thank you, Greg. Before we transition to talking about the state of practice with hard armor solutions, we'd like to have our audience answer a poll question. Okay, you will see it pop up on your screen shortly. Which way do you see the markets turning in your area? Markets are up, markets are flat, markets are down. We apologize to any of those of you who are on a mobile device. We understand that the poll questions do not work, so please don't get discouraged. If you want to answer the question in the question box, that would be great. As a reminder, we will be taking questions throughout the presentation and have some time at the end to answer them. If you have a question for Greg or any of the other speakers, please don't forget to log them in the question box. I will keep the poll open for a few more seconds just to let everybody get their votes in. All right, I'm going to go ahead and close the poll and share the results. Well, it's pretty close. Which way do you see your markets turning? About 47% of you said they are flat, 45% of you said they are up, and 8% said they are down. I would like to turn the presentation over to Barry.
Thank you, Lisa. I'd also like to start with thanking Greg for his contribution to this webinar. It's always refreshing to get a designer's viewpoint on erosion control, and so that's greatly appreciated. Thank you, Greg. My name is Barry King, and I'm the area Armor Tech engineer or manager for the Eastern United States and have been exposed to hard armor systems for close to 9 years now. I'll begin this section of the webinar by summarizing the current state of practice of hard armor products, specifically the ArmorFlex articulating concrete revetment system and the Ajax concrete armoring unit. Hard armor products are often utilized on sites where getting erosion right the first time can determine the overall success of a project. An example is shown here. It's in Raleigh, North Carolina, and ArmorFlex ACBs were were used to mitigate overtopping protection or provide overtopping protection in the site. Supporting the designers in the pre-design phases, as well as with the contractor after construction began, really made the difference with this project. It allowed for a compressed and very efficient timeline. And what you're looking at here, you know, there's project sites which experience a regular assortment of hydraulic discharges from the 2-year to the 500-year event. These are prime candidates for where hard armor can really make sense. The use of ArmorFlex ACB shown here maximize flow conveyance due to the system's relatively low Manning's N coefficient, while also providing hydraulic stability and robustness that's required from a permanent erosion control system. I'll continue on with the hard armor state of practice section of the webinar, focusing on ArmorFlex articulated revetment systems. Topics will include current design standards, testing certifications, and ongoing improvements to serve the industry. For articulating concrete blocks, the current state of practice must begin with the system compliance to ASTM international standards. Very important here. Setting up and administering the overtopping test is the first step to achieve compliance to the ASTM standard. Regarding that overtopping test and setup, you look to ASTM D7277 to satisfy that need. This standard discusses preparation, installation, instrumentation, and other setup considerations required to perform a successful and formative test. After the testing step is completed, ASTM 7276 was developed to provide strict guidelines for the analysis and interpretation of the full-scale test results. From these results, unique ACB capabilities can be determined and applied to the factor of safety method. It is the responsibility of the manufacturers who offer ACB armoring solutions to employ both of these very important design standards. Contec is in full ASTM compliance across all its ArmorFlex ACB offerings. Our recently completed testing programs have provided us, and more importantly with the customers out there, with the most recent performance data and improved construction techniques of any ACB system being applied today. ACB's systems continue to evolve and improve as a result of strenuous testing, but more importantly by drawing from installed projects across the country that have satisfied design conditions. Throughout North America, Contec has supplied more ACB projects that have met or exceeded design conditions than any other manufacturer. Here we've depicted a standard profile of an embankment experiencing steady overtopping flow conditions. Through full-scale testing protocol, ACBs experience significant overtopping depths and associated hydraulic forces such as shear and velocity. As a result, the system performance threshold associated with one or both of these forces can be identified and hotspots in the design can be investigated. For an example, through ASTM testing, specific design details and products have been developed to protect against supercritical flow conditions and the energy released in hydraulic jump. But as designers, where does one look to find proven methods to determine factor of safety against hydraulic conditions? Where can one find real-life design examples to follow? In the case of ACB systems, the National Concrete Masonry Association Design Manual is accepted as the most current and all-encompassing design tool. Industry standards for hydraulic design have been consolidated in this 2009 second edition. Most importantly, with this manual, step-by-step design examples can be followed with straightforward explanations of variables and almost more importantly, design assumptions. In addition to design guidance to ACB systems, this manual also includes filter design assistance, coverage area recommendations, and common construction details. It is a crucial resource. The physics of ACB stability are straightforward as shown in this free body diagram. We can summarize all the related forces into two categories, stabilizing and destabilizing. Stabilizing forces are gravity normal to the slope and interblock and interblock resistance or friction. Destabilizing forces include gravity parallel to the slope, lift, drag, and an overturning moment created by projecting blocks. Maximum projections are allowed. Maximum projection of 1/2 inch are allowed as referenced in NCMA design manuals. To eliminate the overturning moment, a tapered ACB unit with a 1/2 inch taper was developed, as seen in the cross-section above. The top of the block is tapered 1/2 inch from upstream to downstream as shown. The net result effectively negates the destabilizing impact force. These tapered blocks are used in higher velocity applications, typically found in steep channels and in dam overtopping applications. Please note that the tapered system is only available in open cell versions. To function properly, the blocks need to be placed on a free-flowing stone drainage layer. This is to relieve any hydrostatic pressure that may build up underneath the system. The design method for hydraulic stability is constantly being refined and improved. We find out things. We find out things in the field. We find out things from researchers. And in 2011, NCMA released an addendum of the 2009 design manual titled TEK 11-12, ACB revetment design, factor of safety method. This most recent addendum considers the uncertainty of flow direction for a proposed ACB application, which adds another possible layer of conservatism when a designer is faced with questionable design inputs. I will now continue this section with a discussion of the AJAX concrete armoring unit. AJAX concrete armoring units are another hard armor solution primarily focused to mitigate bridge scour and promote energy dissipation. The current state of practice for this product is strongly linked to AJAX versatile installation methods and options. Varying sizes from 24 inch to 120 inches, severe hydraulics can be addressed with this robust armoring system while maintaining straightforward and efficient construction practices. Like the ACB free body shown before, hydraulic forces acting on the AJAX layer are trying to lift and overturn the system. They're trying to overpower the interconnected interlocks of lateral and vertical. Basically, the unit is locked in vertically and horizontally with its brothers and sisters around it. And what this does is it creates a continuum of armoring. And what that means is it creates a system with significant capability to resist uplift and overturning moments. So a very robust system. AJAX have been included in the most recent edition of HEC 23 issued by the Federal Highway Administration, which provides accepted scour mitigation systems and products, incorporated with other design aids such as HEC 20 to assess stream stability and HEC 18 to analyze scour. Selecting the proven AJAX armoring system is the final task to successfully mitigate risk of scour to structures. Concrete armoring units, like their ACB hard armor counterparts, should be subjected to full-scale hydraulic testing to determine performance thresholds. How much water can they take is the question. Contec has made sure AJAX have not only been tested for channelized flow conditions, but like the ArmorFlex ACB system, has been successfully tested in wave attack scenarios as well. I would like to now take a few minutes to discuss a little spillway design. And so getting a little specific here. Primary and auxiliary spillways are a common application for hard armor. Contec would like to share characteristics of its hard armor products which can assist with designing these types of structures, beginning with the design event or discharge of the spillway. It is common for higher recurring events to govern the design of the armoring system being considered. Specifically, higher velocities associated with these events heavily influences the determination of the adequate revetment being chosen. Looking at a typical spillway cross-section, one can see the green flow area associated with higher recurring flows. The higher velocities, lack of tailwater conditions, and relatively low shear forces equate to an ACB revetment with enough hydraulic capacity to remain stable. Factor of safety for stability is often set at 2.0 or higher. Looking again at the cross-section, the blue flow area represents lower recurring flows, which still must be conveyed through the proposed spillway, often due to stormwater or drainage requirements. It is plain to see that this event determines the geometry and ultimately the cost of the structure, but not necessarily the failure mode of the revetment. An alternate factor of safety associated with these lower recurring events can be considered for spillway design. This effectively assures the larger design flow will be passed while balancing everyday flow conditions and requirements of the spillway. Factor of safety for conveyance is often set as at the industry standard of 1.5, and it should be noted that the relatively low Manning's coefficient of ArmorFlex can often enhance conveyance and, in most cases, reduce excavation required. As Greg alluded to earlier, traditional ACB systems can be limited, specifically by flow regimes with high velocity. In these cases, Contact offers the Armor Wedge unit. Tested to ASTM compliance in full-scale conditions and subjected to standard factor of safety analysis, Armor Wedge provides a unique solution to the most severe spillway conditions and can often be used in lieu of concrete or even roller compacted concrete. That concludes my section of the webinar. Right now, we will transition into a poll question, and I will turn it over to Lisa.
Thanks, Barry. I appreciate it. Ladies and gentlemen, poll question should pop up on your screen momentarily. What driver is the most influential in choosing your erosion control type and design? Hydraulics, environmental and permitting, or aesthetics? We do have a few questions coming in. Again, we should have time for questions at the end of the presentation. Please don't forget to log those in the question box. We appreciate your feedback. And I will keep the poll open for a few more seconds to let everyone get the vote in. Okay, let me close the poll, share your results. What driver is the most influential in choosing your erosion control type and design? We have 62% of the audience voting hydraulics, along with 36% saying environmental and permitting, and 3% aesthetics. Clayton, I'm going to turn it over to you, and I know how you feel about the aesthetics. I'm surprised it's that low, too.
Yeah, I think this morning we saw 4% were choosing aesthetics, and by the time you take a look at the ability to have a green look to an underlying hard armor system, in some instances, that it's just surprising. However, at the end of the day, we're here to protect our stream channels, structures with the hard armor solutions. So thank you, Lisa, and thanks to Barry, Jeff, and Greg as well. My name is Clayton Fawcett. I'm the area manager for the ArmorTech business in the western half of the U.S. Been fortunate enough to have been in this industry since 2004, and I'm happy to be here today. I'm glad we get the chance to share some of our successes with such a large and varied audience. I'll be highlighting some of our challenging and interesting projects here in this next section. We were contacted 2010 by the NRCS, who is tasked with managing floodwaters through their structures in North Dakota. The Absaraka Dam spillway had experienced erosion in the past and was in fact flowing again due to spring flooding in the area. Following the overtopping event, it was evident that there was significant erosion on the spillway. And upon closer inspection, severe head cutting and mobilization of subgrade soils had taken place. Erosion of the spillway created a potentially dangerous condition for the downstream residents. In fact, the National Guard was mobilized to stand watch in the dam and sound the alarm in case of rupture. Contact worked with the NRCS Design Office in Des Moines, Iowa, as well as the North Dakota NRCS staff. Ultimately, installation of an ArmorFlex tapered block system was selected by the NRCS staff as a long-term corrective measure to counteract the erosive forces that were occurring in the spillway. In the spring of 2011, the spillway was once again put to the test. Heavy snows throughout the winter and warm spring rains released a large volume of water in a short amount of time in the watershed. As evident in this photo, significant amount of water passed over the armored spillway. Hydraulic jump was expected due to the downstream subcritical control provided by a nearby road embankment. Jump formed on the armored section of the spillway, although it's not visible because it's submerged. The ArmorFlex apron extends to the end of the guideway berm, which juts out diagonally across the top center of the photo. Following several days of overtopping flows, the ArmorFlex system showed no signs of soil migration or soil loss beneath. The system performed as designed. And I just wanted to say a big thank you to the NRCS for passing these photos along to us. Next project we wanted to take a look at is near Rygate, Montana, and that's a Dead Man's Basin impoundment. This reservoir is managed by the Mussel Shell Irrigation District for irrigation purposes. And in a cooperative project with the dam owner, the Montana Department of Natural Resources, the outlet conduit was rehabilitated and updated. Part of the protective measures employed, ArmorFlex and Ajax were placed directly downstream of the outlet works. 48-inch Ajax were installed directly downstream of the outlet with ArmorFlex on the side slopes and in the downstream section. One note is the interaction of the adjacent protective measures must be thoroughly evaluated. In this photo, the concrete grout or hydraulic connection between the Ajax and the ArmorFlex is shown. This is a key detail to maintain continuous protection through this turbulent flow zone. The functioning outlet is subject to severe and varying degrees of turbulent, unsteady flows, depending upon the discharge and tailwater conditions. Mussel Shell Irrigation District was gracious enough to work with Contec and the designer, Western Water Consultants, to run this installation through the paces. Flows from 50 cubic feet per second through 345 cubic feet per second were evaluated. And in this photo, we're showing a hydraulic jump at 345 cubic feet per second directly on top of the 48-inch Ajax. Following the run-up testing, flows were stopped so the installation could be evaluated. The roughness of the Ajax caused sedimentary infill and deposition within the matrix of the previously unfilled Ajax. Next project is a coordinated systems-based approach. Contec was able to work with the city of Kennesaw, Georgia to assist in the solution development of a culvert in need of replacement. Taking advantage of open waterway area of the Contec Conspan bridge structure and additionally open cell ArmorFlex to protect the invert. Speed of construction and local on-site assistance were two of the benefits to the owner on this project. Interaction between all elements once again becomes a key component and functionality of any system. Prior to completion, the exposed cable loops on the ArmorFlex mattress, which are shown in the right and left extremes of this photo, were encapsulated in a hydraulic connection or a grout closure pour, effectively sealing it to the strip footing on which the Conspan units were set. Finished product, note the open area provided by the Conspan structure and additionally how the live bed sediment transport is uninterrupted through this system. Chastain Meadows Regional Stormwater Facility in Marietta, Georgia provided a unique set of challenges for the designer Florence and Hutchison. This photo shows an area adjacent to a nearby bridge in everyday standard operating conditions. And this photo shows the same area in a flood condition. Very large volumes of water flow in this watershed. Project owner, Cobb County, Georgia, understood the need for a regional stormwater facility to mitigate some of the downstream flooding. Plans were finalized and construction was substantially completed in 2011. Both closed cell and tapered ArmorFlex was utilized in this project, as well as 24-inch and 48-inch Ajax. The embankment was protected from overtopping flows, and the downstream basin was also protected from erosive forces. Contec personnel supported this project by attending on-site construction meetings and were continuously available for questions from the contractor and engineers as they came up. On this project, that meant 24-hour support. When our customers are working, we're working to support them. Completion of this project created a stormwater basin capable of handling significant flows. Additionally, measures were provided to protect the downstream bridge and supporting piers, and those can be seen in the far end of the picture and the 48-inch Ajax on the slopes near the bridge. Extraction of low sulfur coal in Wyoming coal mines found Contech working with Western Water Consultants once again to provide erosion protection. This structure was completed as a temporary diversion around a mining cell. This effectively and safely conveys stormwater through the roughly 42 feet of difference in channel bed elevation, as we'll see in the next photo. Large drainage basins produce a lot of water. Here we can see an example of the result of a western storm which produced significant flow over the structure, and that additionally performed well over its life. The McCormick and Baxter Superfund site in Portland, Oregon presented a unique opportunity for the employment of Contech's ArmorFlex system. ArmorFlex was selected for the protection of a sediment cap at this site. Sediment cap was the third and final phase of containment of dense non-aqueous phase liquids, or DNAPLs. Years of operation of the McCormick and Baxter creosote facility on the banks of the Willamette River had taken their toll, and prior to the cleanup of the property, creosote was actively leaking into the Willamette River. This finished photo shows the approximate location of the crane in the previous slide. The ArmorFlex extends from roughly the riprap line out into the Willamette River. And in the background is a drawbridge which functions to allow passage of freight and cargo ships to the upstream Port of Portland facilities. Contech supported this project with almost continuous presence due to its complexity. And then after almost 10 years since the installation, natural vegetation has taken over the upland bank sections over the top of the ArmorFlex. And once again, the Port of Portland can be seen in the background. Contech's 48-inch Ajax was a solution called for by the North Carolina DOT when dealing with scour critical bridge piers on the Bonner Bridge near the Outer Banks in eastern North Carolina. Contractor on this project had no other choice than to work from the water. Here, a barge-mounted crane prepares to lift a module of 48-inch Ajax, as highlighted by the red circle. Contractor then placed them on the seabed near the pier footing. And here's a closer look at the module of jacks. The contractor had to rig their own spreader bar to put them in place, and divers were utilized to release the spreader bar from the module once in position. That's our last project we're going to highlight today. Now we're going to go to one more poll question before wrapping up by explaining how Contech can support you with your designs.
Thanks, Clayton. Ladies and gentlemen, let me launch the poll question. Are you likely to utilize a hard armor solution in an upcoming design? Yes or no? Again, we'd like to thank you for logging your questions. We do have some time at the end here, and I hope you can get yours in so we can get that answered. I will leave the poll open for a few more seconds and share the results. 59% of the audience said yes, and 41% of the audience said no to utilizing a hard armor solution in an upcoming design. Now I'd like to turn it back over to Jeff Gilkinson to discuss working with the hard armor team at Contech.
Thanks, Lisa. Hopefully after this next section, we can take that 59% up to 99%. But we appreciate everybody's time today, and we've covered a lot of information, and we hope that that you've taken away some key information. First and foremost, that the Contech is here to support you in the planning and solution development of your projects, and also to provide design and installation support. Contech has the right portfolio and expertise to support your needs for any type of hard armor solution, and ArmorFlex and Ajax can be used to counter many of the most challenging hydraulic applications. And when you find yourself in hydraulic applications that are the most aggressive, where you typically be considering conventional concrete or roller compacted concrete, Armor Wedge can be a solution that can help you out in those situations. Lastly, the Contech Hard Armor team is always available and willing to help support your efforts as you navigate through your projects. So just to give you one example of the support that Contech can provide, I'll go back to the Chastain Meadows project that Clayton discussed a little bit earlier. Initially, Contech assisted the designer, Florence and Hutchison, with selecting appropriate hard armoring techniques that would meet the challenging hydraulics at the site. The solution development went beyond the normal calculations and drawings to include hands-on modeling, as you see on the left side of the screen, to ensure the proper installation of the Ajax system in conjunction with the embankments that were designed near the bridge structure. So not only did we have to design a structure that could handle the hydraulics, we had to make sure that it could be built in the field. And as Clayton mentioned earlier, Contech provided on-site assistance. It was on call 24 hours a day during construction to support the successful installation of the ArmorFlex and Ajax. At Contech, we're very proud of our hard armor product portfolio, and our team of experts are here to support you in your projects. We definitely thank everybody for their time today, and we hope that when you encounter situations with needs for hard armoring, that you engage the support of Contech so that we can assist you in taking advantage of these solutions as many other designers have in the past. With that, I'll turn it back to Lisa to close out our session for today.
Okay, regarding questions, there have been a few questions come up regarding the PDH certificates. At the close of the presentation, a new browser window should pop up on your screen with a survey about today's webinar. After you submit the survey, your responses will be manually processed, and you should have a thank you for attending email within 24 hours with a link to download your PDH credit. Again, this process is manual, so it will not be immediately following the presentation. We are also including a copy of today's slides in that email, so you can download those as well. Again, this process is manual, so it will not be immediate. If you have any other questions, or if you have not received your email within 24 hours, please contact info@contechs.com. Barry Clayton, are you ready? We have a few questions that have come in. Actually, the first one is for Greg. We did get a few during Greg's presentation. Greg, are you there?
Yep.
Okay. Greg, you mentioned the use of concrete and roller compacted concrete. In situations where both solutions work, how do you typically decide which is the best choice?
Well, that's a good question. I'd start off with thinking about the frequency of operation. For those that would operate infrequently, either solution would be adequate. However, if we were expecting it to operate frequently, I would be inclined to lean more towards the conventional concrete structure. And then after that, probably the next biggest considerations are usually the constructability and cost side of the equation, and what really fits the site. So that's probably the best way I could explain our thought process there.
Okay, great. I have one more for you. What is the typical or minimum width of the RCC lift? It depends on the size of the equipment, but usually somewhere around 8 to 10 feet would be a bench width. Great. Thank you. Those were the ones that were specifically directed to you. I have got a few more that were more in general. Barry, I know you were covering this one earlier. You mentioned low mannings. Exactly how low?
Okay. Yes, great question. It depends on which system you're looking at. So I'll start with the regular ArmorFlex system, like you see here on the left of the slide. That has a range from 0.029 to 0.032 for roughness as a design roughness. You move to the tapered system. That Manning's coefficient goes down. 0.025 to 0.0265. And it sounds, specific going out that far with the digits, but anyone dealing with roughness can appreciate what I'm talking about. And now in moving to I'll even include Ajax in that. So full tested Mannings for Ajax, you can count on 0.1, a very rough unit for that. I hope that answered the questions there.
Okay, great. I hope it did too. Thank you very much. And Clayton, can you explain a little bit more about how the tapered ACB functions?
Oh, absolutely. I'd love to. Typically, our tapered block series is applied in high-velocity applications. And when you start to see those high-velocity applications, they develop, the system can develop a tremendous pore water pressure differential. And so the half-inch taper in the top of the block system was incorporated to all but eliminate the single biggest destabilizing force for our systems. We analyze our systems against sliding and overturning are the two primary modes of failure, and by eliminating the leading edge, by incorporating the half-inch taper, we've all but eliminated that impact force associated with a projecting leading edge into a high-velocity inbound flow. Additionally, the incorporation of a drainage layer of free-flowing drainage stone allows the pore water pressure differential from the top of the system when compared to that of the pore water pressure in the subgrade to be broken down into two more manageable pieces. So now we're relieving a pore water pressure differential between the subgrade and the drainage stone, and then additionally the second piece of that would be the pressure differential between the drainage stone layer and the top of the taper block system.
Great, I appreciate it, and I know the audience does too. Barry, I know you must have handled this one on the earlier webinar. I remember it. We've been asked that a few times. What is the governing design code for ACBs and AJAX?
Yes, very good question. Yeah, and it's an opportunity to clarify things a little bit. In the webinar, you heard ASTM, you heard the National Concrete Masonry Association. Who does what who wears what hat? I guess I can definitively say if there's a code, design code to look for, that can be found under the National Concrete Masonry Association's design manual. It is the most recent, the most thorough, all-encompassing design manual that you can find out there. So that's really where you go to look for design examples, and why it works and how it works mathematically. I mean, we're engineers here. We like to see things get solved, and we like the numbers to work out. That is where you would find that. Now, ASTM, on the other hand, that's a body that what they're providing are necessary protocols, and what I mean by that is you have to test these systems in a repeatable way, because there's manufacturers out there, and so everyone has to be treated with the same measuring stick, and that starts with the testing, going from setup to testing, and then even past that you can get into installation guidelines, which is a ASTM standard for ACBs, and even manufacturing standards, which are also specific to ACBs. So that's more or less the difference, and it's kind of a loaded question with design code that carries a lot of weight. I would say to that you need to go directly to the National Concrete Masonry Association, and that is where you'll find your guidepost, so to speak. I hope you find that helpful.
Great, thanks, Barry. I think we have time for a few more. I have another one. Do you need to remove the sediment that lands in the AJAX unit?
Hey, this is Clayton. I'll take that one. Typically what we see is on the falling limb of the hydrograph, and also it's really dependent on particle size, the amount of sediment carried within the matrix of AJAX is going to really find an equilibrium point, and depending upon discharge, you're going to see a certain section of those AJAX that are exposed. At higher discharges, you'll typically be able to visualize or see more of the arm of the AJAX exposed than you would at lower discharges, and that's really just related to the critical particle velocity of those sedimentary particles deposited in the matrix. There is no need to remove sediment from within the matrix of installed AJAX, as they will perform as designed at the designed roughness in the infilled condition.
Great, thank you. And I have one more, as I see time is winding down. Can you drive over the ArmorFlex units? I'm assuming this is vehicular.
I can take this one. You can break it down into two different parts here. As a designer, road design is a common thing that we see. We've all seen a design section of a pavement section. So the same applies here. If you're talking about a low water crossing, you're talking about articulated concrete block units that are that are installed over a channel that is oftentimes just wet, and you have a little flow through there. Vehicles can travel through there, but occasionally they do see a gully washer, as we like to say, and something like that happens. You have to have an overlay or a system that'll take those hydraulic forces. And so you have a balancing act between improving the subgrade to handle the wheel loads, and you can steer that right to classical road design, improving the subgrade to accept the wheel loads. You can incorporate geogrid to lessen your rock thickness to improve it. There's many different ways out there. We have a standard that we use. And so that's the first part. The second part would be to look at the revetment, or in this case, the armor flex, and size that appropriately. Number one, it's behaving as an overlay, and number two, it's an overlay that has significant hydraulic capacity. So you need to look at the hydraulics in some form for those applications. So that's I hope you found that helpful.
Well, thank you, Clayton, Barry, Greg, and Jeff. We'd like to respect everyone's time, and we are coming to the close of the hour presentation. Again, we thank you for your time and hope you learned something new from our webinar. If you have any questions, please email info@contactes.com, and have a great rest of your day.